In this demo, we are going to describe two mappings that parse and transform weblog data in a HDFS source and writes to a flat file target. Consider a scenario where a trading firm offloads their weblogs daily from their online trading site to a Hadoop distributed file system. The weblogs contain details about visitors who log in to the website and look up the value of stocks using stock symbols. In the developer tool, in the project log processing, we see a mapping designed to read the parsed weblog data and write to a flat file target. The source is a logical data object read mapping and the target is a flat file data object. In the developer tool, in the log processing project, we also see the logical data object read mapping that reads data from a HDFS source, parses the data using a data processor transformation, and writes to a logical data object. We use a logical data object mapping to access and transform the data without modifying the underlying source. Now, let us look at the logical data object read mapping LDO weblogs. The log processing folder contains the physical data objects and the logical data objects used to develop this mapping. We see in the editor the logical data object read mapping designed to parse the weblog data and write to a logical data object target. The mapping has a HDFS source called weblog. It contains a data processor transformation that parses the input data. Then, a joiner transformation combines the activity of visitors who return to the website on the same day with stock queries. Following that, an expression transformation adds the current date to each transformed record. The output is written to a logical data object target called sample weblog. Now, let us look at how the data objects in this mapping are configured. The source is a Hadoop distributed file system. Use a complex file data object to read unstructured weblog data from a Hadoop distributed file system. The resource location for complex file data object is remote on HDFS. Use a HDFS connection to access the Hadoop distributed file system. The read view shows that the output of a complex file data object is a binary stream. Now, let us look at the data processor transformation configuration. The data transformation application contains a data processor transformation called POC session. Let us look at how the data processor transformation is configured to process the input binary stream of data, parse the data, and write to XML format. The data processor mode is set to service and output mapping, which executes the service, and the output is an XML hierarchy. The service startup component is set to a streamer. A streamer component splits up large input data into segments. In this configuration, the streamer script reads the data from a begin position when it finds the text visitor ID. The streamer sends the data to the run component visitor parser. The parser component parses the input data and writes XML output based on the XML schema object. View the XML schema object defined in the References tab. The schema defines the elements and attributes that occur in the XML output. To view the element properties set in the POC session schema, select the element type. The developer tool displays the different fields. We can run the parser to view the XML output for a visitor ID. Now, let us look at the joiner transformation that combines the event records for a specific visitor ID. The joiner transformation performs a normal join based on a simple condition when there are duplicate visitor IDs in the data. Next, the expression transformation adds a date column and a value to each record. The output is written to a logical data object target. That completes this demo. To summarize, we described the mapping mParseWeblog that has a logical data object read mapping called LDO weblogs as a source and writes the parsed data to a flat file target. We then described how the data objects in the logical data object read mapping are configured to parse and transform the weblog data.
If you have feedback on this demo or to request a demo on another topic, email us at infa_documentation@informatica.com. You can also tweet us on the INFA Support Twitter site.